Welcome, friends. In the realm of artificial intelligence and machine learning, where algorithms decipher the language of data, and insights await those who seek, welcome to Decoding Data Patterns, Journey into AI/ML with K-Nearest Neighbors. I am your guide on this expedition into the fascinating world of the KNN algorithm. The K-Nearest Neighbors, KNN, algorithm is a popular machine learning algorithm used for classification and regression tasks. In KNN, the K represents the number of nearest neighbors that are considered to determine the class or value of a data point. Here's how the KNN algorithm works. 1. Load the training data. Start by loading the labeled dataset that consists of input features and corresponding class or target values. 2. Determine the value of K. Choose an appropriate value for K, which represents the number of neighbors to consider. 3. Calculate distances. Compute the distance between the test data point and all the training data points using a distance metric like Euclidean distance or Manhattan distance. 4. Find K nearest neighbors. Select the K nearest data points based on the calculated distances. These data points will be considered for making predictions. 5. Perform majority voting. For classification tasks, determine the majority class among the K nearest neighbors and assign it to the test data point. For regression tasks, calculate the average or weighted average of the target values of the K nearest neighbors to predict the target value of the test data point. 6. Make predictions. Repeat steps 3 to 5 for all the test data points to make predictions for the entire dataset. The provided code illustrates the use of the K-Nearest Neighbors (KNN) algorithm as a classifier on the Iris dataset. After importing essential Python libraries, the Iris dataset is downloaded and assigned column names. The dataset is loaded into a Pandas data frame, and data preprocessing is carried out by extracting features and target labels. The dataset is split into training and testing sets, with 60% used for training and 40% for testing. Data scaling is performed to standardize feature values. The KNN classifier is instantiated with 8 neighbors and trained using the scaled training data. Predictions are made on the test set, and various performance metrics include the confusion matrix, classification report detailing precision, recall, and F1 score for each class, and the accuracy score. The code showcases the process of using KNN as a classifier for predicting iris flower species based on measured features, providing insights into the model's accuracy and performance. The provided code snippet demonstrates the use of the K-Nearest Neighbors (KNN) algorithm as a regressor on the Iris dataset. First, essential Python libraries are imported, NumPy for numerical operations and Pandas for data manipulation. The Iris dataset is downloaded from a URL and loaded into a Pandas data frame. The feature data, sepal length and width, is extracted into X, and the target data, petal length, is stored in Y. The KNN regressor is imported from Sklearn and initialized with 10 neighbors. The mean squared error, MSE, is calculated to assess the model's performance by measuring the average squared differences between the predicted and actual target values. The code showcases how KNN can be utilized as a regressor to predict a continuous target variable based on nearby data points. Overall, the KNN algorithm is a powerful tool in the field of machine learning, offering flexibility, simplicity, and effectiveness in various classification and regression tasks.